Hello, welcome to another quick bite. Today we're going to look at setting up the universal motor controller and running it with some nice demonstration code that also includes some HDMI monitor output monitoring. So let's have a look at how you get started. Well, here's the hardware. So we're using the mini breakout board again, universal motor driver on the right hand side there. P2H module down the bottom. You could also use the P2H with the RAM on, the P2EC 32 megabyte if you wanted for this demo. Wouldn't matter. Digital video output board just on the left there, that's got a HDMI port to give us connection out to a monitor. I'm not showing the monitor here, but we're using for this demo the small parallax 7-inch monitor that I'll link in the description, but you could also use any HDMI monitor or TV or whatever you might have. And then the prop plug for programming as usual. So we plug it all together. Make sure you get the edge module the right way around as usual. There's a white orientation ring drawn on the top edge of the edge module you can just about see, and there's one that matches on the mini breakout board. So yeah, plug that in the right way around. I'm using a 12 volt lead acid battery for this test. You could use a bench supply or a number of other voltage sources, but I just happen to have that one handy. And there's the little cute motor we're using. So it's a 3-phase motor. There's green, blue, yellow cables there for the 3 phases, and there's a bunch of other cables for the Hall sensor outputs. You need to do a little bit of work to prepare this motor because, as you can see, the cables come with bare ends, and also the motor itself has a what do you call that thing, the sticky out nosy bit that rotates, spindle, that's the word I'm looking for. So it's got its spindle sticking out, but you probably want a coupling to be able to turn things, and so I've just found a strip of screw terminals there. I've just cut one open carefully with a knife to get the brass bit out the middle, and you can see pointed to by the pencil there. It's a handy way of coupling things between the spindle of the end of the motor and other things. I've just made up a little kind of hand holder thing there using a pipe holder, as you can see, with an M5 nut and bolt through it. But anyway, use your imagination there. The other thing that you need to do is make up the cables. Well, for the 3-phase cables, the yellow, blue, and green larger cables there at the top of the screen, they are the motor phase cables that connect to U, V, and W on the board. They can stay as bare ends because the motor driver has spring clip terminal blocks, so they just go straight in. But for the Hall sensors, you need to come up with a solution just to connect those. And so I've just got a bit of old Vero board and a 5-pin or 5-socket female header and some screw terminals, and just soldered those together on a little piece of Vero board there, and just made up a little adapter header. But yeah, again, you sort of use your imagination. If I had some crimp headers, I probably would have crimped those on the end of the wires just to plug on, but I didn't have any, so yeah, use your imagination there. The other motor, incidentally, that we sell, the 6.5-inch hub motor, the much bigger one, that comes with the header already installed, but this smaller, lower-cost motor doesn't, so it's left to your own devices. Well, finally, the battery. So yeah, battery, and to make sure you do use a fuse, of course, if you're using a battery. I've just used an automotive fuse. Really, because that was handy because it came with the cable already on, so that was saved me a job of making up one of the cables at least. But yeah, so there we go. So that's all plugged together, and let me see if I can now bring up the code to show you what's going on. There we go. So I've downloaded the code again from GitHub. This is from Iron Sheet Production. Stephen Morocco has kindly created all this code. It's zipped in this. You can download it from this quick byte, or go to his GitHub for the latest version. So I've opened the demo single motor file, which is on screen now. He does have various versions set up for various demos in the same download package. So you'll find a dual motor configuration if you happen to be running two motors, such as a robot might have, one wheel left, one wheel right. He's got a version that can be controlled by serial input. So I believe he was controlling it with a Raspberry Pi serial interface, but you could use any microcontroller, obviously, on this planet with a serial interface to control it. So it can be controlled, by Pi, Arduino, whatever, anything else, including all the Parallax products as well, of course. It can also be controlled using a radio control device. He's got a version which is already set up for the FlySky remote controller, and it probably wouldn't be much of a stretch to convert that for other radio controller transmitters as well. But for now, we'll just stick with the single motor controller just to show you the basics and to get up and running quickly for a test. So as usual, the things to look at before you get started are in the CON configuration setting. So HDMI base pin is where you've plugged in your the digital video out, or the HDMI connector. So that's pins P8 to P15. That's where I've plugged them in on the board, so that's all good. And well, seemingly that's the only thing we need to set here. Oh, well, and perhaps just have a look at what you want your maximum speed to be. So for the video, and because I don't have a great mounting on the motor either, I don't want it spinning off the table. So I've reduced the maximum speed down to 10. So that's actually probably quite a good thing for you to just do, especially before you run the motor the first time, and then carefully increase your speed as you're certain that your motor is held down. These motors do rock. They do run really, really fast, so they will rip off their they can rip off their mounting and fly across the room if you're not careful. So you do need to treat them with some respect. So yes, I wouldn't suggest you start at 100% full speed to start with until you get a feel for how the thing's going. So yeah, so set that, and otherwise you're probably good to go. So what else? Oh, well, there is one other file on there called the ISP BLDC motor user config. So you probably want to have a look in there as well, because in there you can actually set the type of motor you're using. There's various comments all the way down here, and then here we've got the author's different test configurations for duals and single motors and whatnot that he's been using. So I'm using this Doco 4K RPM motor, so that's the one I'm using. Yeah, this is where you set the pins for the universal breakout, P16 to P31. Here I've set the drive voltage to 12 volts as I'm using a 12-volt battery, and then the wheel diameter I don't need to use because I haven't got a wheel attached, so we don't need the thing to be feeding back distance in the demo I'm doing, but you might want that. Just below that one, there happens to be a preset settings for the 6.5-inch hub wheel, the bigger wheel you can get from our store. So yeah, you can comment those out, and to comment them in and out, you just delete that dash there and then introduce, oops, wrong button, introduce one there, and now it's in black. You can see that's the active configuration. So I'll leave that as is, as that's my motor, and just click save to make sure. But that's all you need to change in there. Just those settings to choose what motor you're using and where it's plugged in, basically. So back to the main page, so demo single motor, and we're going to press F10 in a minute to upload it to the device. So I'll just switch over to camera view so you can see what's going on. There we go. And I wonder if I can bring the code in. Yeah, battery's attached. So, right, so let's do F10, and that should load up, and off goes the motor. The code is just going to spin the thing forward and backwards a couple of times, or once even, it looks like. And you can see in the background the monitor is updating with its live data. Now, let me see if I can zoom in on that. But I just wanted to point out that you do get a lot of diagnostic data with this. Oopsie, with this source code. You can obviously consume the data as you want. For now it's just being shoved onto the monitor display. But there's all sorts of information coming from the driver, such as current hall motor, position, speed, various error states, and whatnot, RPMs. So yeah, you can consume all that sort of feedback coming from the driver, from the HDMI display. I think that's all. Let's have a look at one thing, perhaps, is the store. So you can find here, if you're looking for these motors, if you go to the Parallax web shop, have a look at the catalog menu on the left-hand side and just scroll down to the servos and motors section, and then open that up and click on motors, and you'll find the various motors. So the larger hub motors are here, that I mentioned just now. You can buy them with or without the mountings. I strongly suggest the mountings. They're super useful and make it very easy to install on a product. And then just below here, we've got the smaller motor that I'm actually using for this test. Although it says rated for 24 volts, it's quite happy running at 12 volts as well. So yeah, so that's all, I think. And then under motor control, you can find the universal motor driver, although we'll have links on the article as well. So I think that is all. Let us know if you have any questions, as usual, in the forum or down below, and thank you for watching.